Hello friends, myself R.D. Mahajan presenting my video on the topic Fourier series for even and odd function in the interval minus L less than or equal to x less than or equal to L. Means whenever it is minus L to L type of interval, we can check whether the function is even or odd. First, we try to see the definition of even function. If f of minus x is equal to f of x, then that function is called as even function. For example, x square. If we replace x by minus x, we get same function x square. Cos x, cos of minus x is cos x. That's why it is an even function. Mod of x is again an even function. X into sine of x. If we replace x and sine x by minus x, it becomes minus x sine of minus x. Sine minus theta is minus sine theta, therefore that minus and this minus sine, it become plus, means same function with same sign, and that's why it is an even function. Cos hyperbolic is also an even function. Therefore all these are the examples of even function. Then odd function, if f of minus x is equal to minus f of x, then that function is said to be an odd function. For example, x cube, sin x, sin hx, x square into sin x, all are the examples of odd function. As we are getting same function but with negative sign, if we replace x by minus x, minus x cube, we get minus x cube. Sin of minus x is minus sin x. Sin h of minus x is minus sin hx, and like this. In this last example, x square even function, sin x is an odd function. A product of even and odd function is an odd function. Then we use one important property of definite integral. When that function is defined in the interval minus a to plus a, then we know that integration from minus a to a f of x dx having two values 0 if function is an odd function in the interval minus a to a, and its value is 2 times integral from 0 to a f of x dx if that function is an even function. Therefore we have to apply this property to obtain the formulas for even and odd function, Fourier series for even and odd function. Therefore, first of all, I will derive the formula for Fourier series for odd. Full range Fourier series is given by a0 by 2 summation of an cos of n pi x by L, and changes from 1 to infinity, summation bn sine of n pi x by L, and changes from 1 to infinity. We call this as equation 1, where a0 is given by 1 by L integral from c to c plus 2L f of x dx, an as 1 by L integration from c to c plus 2L f of x cos of n pi x by L, and then its integration with respect to x, and bn 1 by L integration from c to c plus 2L f of x sine of n pi x by L and its integration with respect to x. Then we try to obtain the result for even odd function. Therefore, Fourier series for odd function, Fourier series for an odd function in the interval minus L to plus L. And therefore, here the value of C is minus L and C plus 2L is L. C is minus L, C plus 2L is L. Substituting the value of C as minus L, it becomes 2L is equals to L plus L we get it is 2L, and therefore we get L as L, upper limit as L, and therefore that A0 becomes, it is 1 by L, C is minus L and C plus 2L is capital L and function f of x dx, which is an odd function, and as per that property, if it is an odd function, its value is 0 as per that property. Then an is given by 1 by L integration from C to C plus 2L minus L to plus L f of x into cos of n pi x by L dx, and that is equals to here function f of x is an odd function, cos is an even function, product of that even and odd function is an odd function, and as per that property its value is once again 0. Okay, then Bn is equals to 1 by L integral from C to C plus 2L integration from minus L to plus L f of x into sine of n pi x by L dx. F of x is an odd function, sine is also an odd function, and therefore product of that two odd function is an even function, and as per that property it becomes 2 times integration from 0 to a, here 0 to L, f of x into sine n pi x by L and its integration with respect to x and divided by this L. Therefore, these are the values of A0, An, Bn, and therefore if we put that values here in equation 1, that Fourier series becomes, therefore when function is an odd function, we have A0 is equals to 0, An is equals to 0, and Bn is given by 2 by L integration from 0 to L f of x sin n pi x by L and its integration with respect to x. Therefore, these are the values of A0, An, Bn for an odd function in the interval minus L to L. Similarly, we try to find out Fourier series for an even function. If the given function is an even function in the interval minus L to L, then once again we try to find out the value of A0. It is 1 by L the value of L is L. Lower limit C is minus L. Upper limit is L. F of x dx. A function is an even function. And integration is between minus a to a. Therefore, as per that property, its value is 2 times integration from 0 to a. A is here L. F of x dx, and divided by this L. Therefore, a formula to find a0. An is given by 1 by L. Integration from c to c plus 2L. Lower limit is minus L. Upper limit is L. F of x, an even function, multiplied by cos function, cos of n pi x by L. It is a product of two even function. That product, resultant one is an even function, and therefore by that property it is again 2 times integration from 0 to L f of x cos of n pi x by L, its integration with respect to x, and divided by L. Therefore, result to find an, and then finally bn is given by 1 by L c to c plus 2L, 1 by L c minus L, c plus 2L, upper limit is L. F of x is an even function, multiplied by sine n pi x by L. Sine is an odd. A product of even and odd function is an odd function, and that's why its value is 0 as per that property. And therefore, we get the value of a0, 2 by L, integral from 0 to L, f of x dx. An, 1 by L, an, the value of an is 2 by L, integral from 0 to L, f of x cos n pi x by L, its integration with respect to x, and bn is 0. And therefore, 0 is 2 by L, integration from 0 to L, f of x dx. An is again 2 by L, integration from 0 to L, f of x cos n pi x by L, and its integration with respect to x, and bn is 0. Therefore, if we put the values here in equation 1, whatever the result we are getting is the Fourier series for an even function. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel to get new updates. Thank you very much.